These are the trig notes over establishing identities. This is very similar to what we did with our 6.1 notes, the notes from the day before. This time, however, what's different is they are actually giving you the answer that you are trying to get to. So on the left-hand side of the equal sign is the question, and on the right-hand side is the answer. And so they're kind of just, your job is to just find the path that gets you from the left to the right. So the first thing we want to do for each problem, box the right side of the equation, and we're not going to change it. So that cotangent theta is going to stay there. We're not going to touch it at all. We're going to work on the left-hand side to see if we can simplify. Step 2, if there's any distributing or foiling, do that next. It's going to make it easier to do as opposed to working with fractions. And then step 3, simplify. You've got lots of different tools to simplify Pythagorean identities, which are on the back of your unit circle here, as well as your regular identities down here. So just kind of keep those in mind on your orange unit circle, on your unit circle. All right, so let's fit back our actual problem here. Cosecant, I'm going to write as 1 over sine. Again, that's coming from right here. Cosecant is 1 over sine. And then cosine, I'm just going to write as cosine theta over 1. At this point, the 1's can cancel. Cosine and sine don't cancel, but I can make that one fraction. And then we'll look at our trig identities again and look for cosine over sine. Cosine over sine right here. It's going to get us an answer of cotangent. And the answer of cotangent is the answer that we were trying to get to right there. So that's how we know we have done it correctly. All right, problem number 2. We're going to box this 2 at the end. That's what we're trying to get to. And although I see parentheses, that's actually not distributing or foiling because there's not 2 things within the parentheses. So I'm just going to start writing everything in terms of sine and cosine. Tangent is sine over cosine. Now I'm going to use a multiplication symbol instead of the parentheses. Cotangent is cosine over sine. And then anytime you have a plus sign, go ahead and write it really large, over-exaggerate it, because we have to remember that we cannot cancel over a plus sign. Sine of theta over 1. Cosecant is 1 over sine theta. So again, when you think about it, you can cancel anything within that multiplication group and anything within that multiplication group, but you can't go from one to the other. So here, sines cancel. Cosines cancel. When everything cancels, you get a 1. If you're multiplying and everything cancels, you get a 1. Here, sines cancel as well as the 1's cancel. And again, you get another 1. 1 plus 1 makes that 2 that we were trying to get to at the beginning. All right, next problem. This is a good example of when we should FOIL. So let's write a big old note here. We want to make sure we FOIL first, even though, yes, you could turn cosecant into 1 over sine. Then that gives you fractions, and FOILing is more difficult with fractions. All right, we're going to multiply cosecant times cosecant. Cosecant squared. Cosecant times 1. Cosecant. Negative 1 times cosecant, negative cosecant. Negative 1 times 1, negative 1. Always look for something to cancel here. Here I have a positive cosecant and a negative cosecant. So when I'm adding those together, those turn out to be 0. So I can cancel them out. And then I'm left with cosecant squared minus 1. Anytime I have something squared, I'm going to look at my back of my unit circle for my Pythagorean identities. And right over here on the right, we can see that cosecant squared minus 1 gets us cotangent squared. So I can just write this as cotangent squared theta, which is what we needed to get to. There we are. Problem number 4. Again, I see some squares, so I'm thinking I'm probably going to end up using one of these identities, but I have to do some work in order to get me there. So I'm going to write secant as 1 over cosine. Cosine is cosine over 1. I'm just going to leave this cosine squared as is. Maybe we put it over 1, maybe not. Not really sure what to do with that quite yet. I'm going to make sure I box this sine squared. Really don't need that equal sign. There we go. All right, and again, we can cancel anything that's within multiplication groups. So that cosine and cosine can cancel. The 1 and 1 can cancel. When everything cancels in multiplication, you are left with a 1. And now that I look at this, I don't think I need this over 1 right here. So I'm going to go ahead and drop that off. You can always put on a over 1 or take it out when you don't need it. 1 minus cosine squared. Look at the back of your unit circle. 1 minus cosine squared. There we are right there. 1 minus cosine squared gets me sine squared. And then I have, again, exactly what I started with. All right, on example 5, I notice a lot of squares. So again, I'm thinking that I'm probably going to use one of these Pythagorean identities. But the way it is right now, it's a little too complicated for me to actually be able to use it yet. So I'm going to see if I can simplify anything out. For cosine squared, anything squared, you are allowed to either keep it together as cosine squared, or you could split it up as cosine times cosine. So depending on the situation of the problem, it's kind of your choice how you want to do it. Because I notice that every single thing on the left is squared, I'm going to go ahead and leave it as cosine squared theta as one big piece, as opposed to breaking it up like this down here. But always know that that's an option. All right, now tangent squared I am going to turn into sine squared over cosine squared. And we're allowed to do that. If this is a square right there, you can make both of the sine and cosine squared, and that counts as tangent squared. We'll put a big old plus sign in the middle so you don't accidentally cross cancel over it. Sine squared stays sine squared. Put it over 1. Cotangent squared. Cotangent is cosine over sine, so we'll just square both of those. Again, we're trying to get that to be a 1. So we can cancel anything within that multiplication group and anything within that multiplication group. Leaving us sine squared. We could put it over 1, but again, since I'm trying to get it to be one of these trig identities, these Pythagorean identities, and none of these are fractions, I'm probably going to leave off the over 1. Over here, I have cosine squared theta over 1 technically, but again, I'm going to leave that. And if I look on the back, I see right here that sine squared plus cosine squared is equal to 1. There we go. All right, problem number 6, a little bit more complex. So give yourself a little bit of extra room to write here. Don't write too large. First thing we're going to do, box this cosecant squared on the right, and we are going to distribute. Again, easier to distribute and FOIL at the beginning as opposed to later on. Cosine times tangent is just going to be cosine tangent. If you want to put a dot in the middle, you can. If you don't want to, you don't have to. And then a big old plus sign again. Cosine times cotangent would just be cosine cotangent. Again, if you want the dot, you can. If not, that's okay. Then we're going to try to turn these into sines and cosines. So cosine over 1. Tangent is sine over cosine. Big old plus sign. Cosine is cosine over 1. Cotangent is cosine over sine. And again, we can cancel within our multiplication groups, but not over a plus sign. not over plus sign. So on the left, cosine and cosine cancel, leaving us with sine of theta. And again, I'm not sure if I want this 1 or not. I can put it here, and if we need to, we can always erase it. Big old plus sign here. And then on the right-hand side, when you have this second multiplication group, nothing cancels. Cosines don't cancel. In order for them to cancel, you have to have one at the top, one at the bottom. So we actually end up with cosine squared over sine. Now, right here, it's very tempting to want to cancel the signs. So at the very bottom in big letters, don't cancel over a plus sign. Don't cancel over a plus sign. All right, so if we can't cancel the signs, what can we do? We're actually going to need to add these as two fractions. In order to add fractions, we need common denominators. So our denominator is going to be sine, because this one's already a sine on the right. So I'm going to multiply this side by sine, and as long as I do it on the top and bottom, I'm good. So then we get sine times sine, sine squared. Sine times 1 is sine. Plus, I'm just going to copy this down on the right. Again, I still can't cancel, but at least now, because I have common denominators of sine, I can bring these two fractions together. Sine squared theta plus cosine squared theta. And if we just look at this top part right here, that's actually, again, one of our Pythagorean identities. This one that we already have circled right here. Sine squared plus cosine squared. So when I see sine squared plus cosine squared, I am allowed to replace it with 1. So I end up getting 1. The sign at the bottom still has to stay there, sine theta. And 1 over sine theta, back to the front side of our circle, 1 over sine is cosecant. So this gets me cosecant. And after a lot of steps, that is exactly what we started the problem with way at the very, very beginning.